So dear 9th class students, now we are starting the chapter circles. In that we are going to introduce various terms relating to circle. First and foremost, chord. Okay, chord means the line segment that joins any 2 points on the circle is known as chord. So this is a line segment joining 2 points A and B on the circle. So here AB is chord. Just I am showing you what is chord here. I think you understood what is chord. Next, circumference. The length of the complete arc that covers the circle is known as circumference. The length of the complete arc that covers the circle is known as circumference. Or you can simply say the length of the complete circle is known as circumference. So that is circumference. Next, arc of the circle. Arc means a continuous piece of the circle is known as arc of the circle. See, this is A, this is B. So this is a continuous piece of a circle. So this is called arc of the circle. So a continuous piece of the circle is known as arc of the circle. In the adjacent diagram, APB is an arc, AQB is also an arc. Particularly APB is smaller than AQB, so APB is known as minor arc and arc AQB is known as major arc. Now, semicircle. Before going to semicircle, you know what is diameter. Diameter, a chord of a circle that passes through center of the circle is known as chord. It's a diameter. Diameter is a particular chord. It is also chord only. Diameter is also chord, but it passes through center of the circle. So see this diagram. In this diagram, chord PQ passes through the center of the circle. So that chord PQ is known as diameter. So a chord of a circle that passes through the center of the circle is known as diameter. Next, semicircle. A chord of a circle which passes through the center of the circle is known as diameter. That's what we have discussed. Now, a diameter divides the circle into 2 equal halves, which are arcs. Okay? A diameter of the circle divides the circle into 2 equal halves, which are 2 equal curves. okay, which are two equal curves. Each of them is known as semicircle. So here the curve, the arc AQB, QAP, QAP. So the arc QAP is known as a semicircle. Next, again the arc QBP is also known as another semicircle. Did you understand? Once you listen carefully, please. The diameter of a circle divides the circle into two equal halves, okay, which are two equal arcs. Each of them is known as semicircle. So here the arc QAP is semicircle, arc QBP is another semicircle. I think now you understood what is semicircle. Next, segment of a circle. Segment of a circle. See, the region bounded between a chord of a circle and the connecting arc of the circle is known as segment of the circle. See here, the region bounded between chord AB and arc APB is this shaded in the diagram. That is known as segment of the circle. And this AQB is another segment, because this is also region bounded between chord and connecting arc. So here you are seeing two shaded regions. In that with minus we have shaded, it is a minor segment. With the plus symbol which we have shaded, it is known as major segment. So segment means the region bounded by a chord of a circle and the arc of the circle connecting the chord, okay, is known as segment of the circle. Next, sector of a circle. Sector of a circle means the region bounded between two radii and the connecting arc is known as sector of the circle. See, for this circle, C is center, CA is one radius, CB is another radius, and okay, this is the arc connecting the two radii, which is arc APB. Now the region bounded between this arc and this radii, this region is known as sector of the circle. So this is smaller than comparing to this. So this is called minor sector. This is called major sector. Understood what is sector? Next, angle subtended by a chord at the center. What do you mean by angle subtended by a chord at the center? See, this is a circle, say with center C. Say this is, okay, chord AB. Now join CA and CB. Then this angle ACB, whatever it may be, say it is theta. So in the above diagram, the angle ACB, which is equal to theta, is known as angle subtended by the chord AB at the center. This is a terminology you have to understand. Understood? Now, dear students, we have discussed various terms relating to circle. Now we are going to discuss theorems. Now, first theorem is equal chords subtend equal angles at the center. So, when the chords are equal, the angle subtended by the chords at the center also equal. That's what is giving the information. So, given a circle with center O has chords AB and CD such that they are equal. So, AB is equal to CD. So, it is given. So, what we are required to prove? The angle subtended by these chords at the center are equal. So, angle AOB is equal angle COD. That is what required to prove. Now, we prove. Okay. So, in triangle OAB, to take in triangle OAB and in triangle OCD, so we have OA is equal OC. Why? Radii. Next OB is equal OD. Why? Again radii. AB is equal to CD. Why? It is given. So, all the three sides are equal in these two triangles. So, that by SSS congruency criteria, you can conclude that triangle OAB is congruent to triangle OCD by SSS congruency criteria. Therefore, by CPCT, we have angle AOB is equal angle COD, and it's proved. Understood? Dear students, now we are discussing the converse of the previous theorem. If two chords subtend equal angles at the center, then the chords are equal. So, this is the converse of the previous theorem. So, given a circle with center O has chords AB and CD such that they are subtending equal angles at the center. So, angle AOB is equal angle COD. Required to prove is AB is equal to CD. Proof in triangle OAB and in triangle OCD. Okay. So, here he gave that these angles are equal. So, you can mark like this. So, now in these two triangles, okay, OA is equal to OC, radii. Okay. Angle AOB is equal angle COD. It is given now. Are you following? Next, OB is equal to OD. Again radii. Again these are radii. Therefore, by SCS congruency criterion, triangle AOB is congruent to triangle COD by SCS congruency criteria. As these two triangles are congruent by CPCT, then you have by CPCT you have AB is equal to CD. Hence, the theorem is proved. Understood?